Well, we had a nugget transitioning your IPv4 to IPv6 basic networking skills for configuration and troubleshooting. Let's take a look at the routing protocols. I'm going to talk about EIGRP for IPv6 and OSPF for IPv6, which is OSPF v3. Go through the facts about them, like what's new, what's changed. Is actually not much. And then look at a configuration example of each one of these on some live equipment. So EIGRP for IPv4 and IPv6 are really twins. I mean, they are virtually the same protocol, and Cisco really poised themselves. I don't think they meant to do it, but they poised themselves in a great way to make a quick transition because EIGRP already supported multiple protocol modules. When I first started teaching Cisco, I remember it wasn't that big a deal, but it was somewhat like ooh, that's a cool feature. When I would say, oh well, EIGRP can also do routing for IPX, SPX, and AppleTalk. Okay, that makes me feel old. Nowadays, nobody cares, but the beauty was EIGRP was designed almost like a Mack truck, right? And it's kind of like it can carry whatever cargo you want. That could be, or a shoe with wheels, one of the two. This could be IPX, SPX packets. It could be AppleTalk. It could be IPv4, or now it's IPv6. So it's very easy for Cisco to make this jump over. Now, the hello packets are still used, so it still forms neighbor relationships like it did with IPv4. However, instead of using what was it in IPv4 224.0.0.10, I believe in IPv4 the multicast hello address was 224.0.0.10. Now it's FF02::A. So it's not saying a link local, it's saying A, like this is the actual multicast address. So all the routers that are connected to that same network segment tune into this little FF02A frequency, and so they can all hear each other's hello packets. Now, notice I said it's a link local multicast. That means local link. It's not going to somehow bleed through and neighbors are going to form from this guy to this guy. It stays on that connection only. Now, here's where it gets fun. Metric, the same. Engine, the same. Load balancing, the same. It's kind of like the same the whole way. It still uses the same metric as it did in IPv4. Still uses dual, the diffused update algorithm, because again, the Mack truck is the same thing. I got to make that somewhat like a Mack truck or a small train. And so we've got dual, which is the algorithm that calculates the routes. That's the same. Nothing's changed. Still does unequal load path load balancing across multi paths. It's the only protocol in the industry that does that. OSPF, all of the competitors only do equal path support. And then finally, it is, well, and I'll say this for all routing protocols in the IPv6 world, they're enabled per interface instead of using the network command. So you remember in all our configurations, we've been typing in router, EIGRP, autonomous system number, right? And then we type in network and what networks we want to enable EIGRP for. That is gone. What a great place to transition into the configuration. So here's what I'm going to do. Let me bring up my little pen tool here. I'm going to actually create some IPv6 networks here in this GNS3 world. So I'm going to make this 2001 colon let's go 0012, colon, as the subnet. So this will be this network. This guy will be the .1 address. This guy will be the .2 address. Then right here, I'm going to make this guy, this network, 2001 colon 0. This is a new drawing tool for me. I'm kind of, it's like I'm drawing with the big old fat, those smashed markers that you used to find on the whiteboard in school. That's what I feel like. It's like these big fat markers. So /64 there, and this guy will be the .3. I'm just taking the router names, and this guy will be the .2 address. So I want to set up EIGRP to kind of exchange routes and communicate. I might as well throw an IPv6 network up there as well. So let's do this. Let me. How do I get out of this pen tool? There we go. I'm going to bring up router 1. I'll show you the config of this first one, then it'll do the rest behind the scenes. I'm using the topology. It was a Cisco, CBT Love. Nugget Love. There we go. So I'm going to go into global config mode. I'll do IPv6 unicast routing to turn on routing on router 1. And then let's go into, let's do a show IP interface brief. I think it's fast Ethernet 0/0. It is, okay. So we'll enable interface fast Ethernet 0. Let's do IPv6 address, and we'll do 2001 colon 0. well, I don't have to put the zeros, but we'll put ::1/64 as its IPv6 address. And let's go into the serial interface and just give it something there as well, so we have a couple more routes in the table. Serial 0/0, I'll do IPv6 address 2001 : well, let's go 0011:1/64. Exit out of there. So we've got two. Let's do a show IPv6 interface brief. So we've got now two different addresses on there. Okay, good. Well, I said I'd do the rest. Well, let me just do router 2, right? So we can do a quick ping, make sure everything's working, and then we'll add EIGRP to it after I throw router 3 in the mix. So nugget love. Log in here. Let's do a show IP interface brief. Config T, interface fast Ethernet 0/0. Oh, IPv6 unicast routing. Can't forget that. Cast. I'll just hit enter. Now IPv6 address. Whoa, I'm going off the bottom of the screen. Forgive me. And this was 2001:12::2 because this is router 2. And then let's go into that serial port. That'd be interface serial 0/0 IPv6 address. And we'll go, this was, what was that, 2001, good. So now I just want to ping between the two routers, ping IPv6 2001:12:1, which will be router 1, and good. Okay, so we're communicating. We verified that we have connectivity now between router 1 and router 2. Let me do router 3, then I'll bring it back. All right, there we go. Router 3 is done. I also verified that we could ping from router 3 to router 2 on this network diagram. Okay. Now you ready for EIGRP? I kind of laugh because I'm like, it's almost not even worth showing. It's so easy, but of course I want you to see it. It really is easy. So watch this. I'm going to go into global config mode, and I'll do IPv6. Everything's IPv6 now. Router. We'll do. Oh, seriously? Come on now. Hello. My name is Jeremy. I've been searching the web for the last hour trying to find the right version of the iOS that runs EIGRP for IPv6 on the 2691 router, and I've found it and replaced it, and now it's running. Sometimes I'm jealous of you. You get to see their, like, kind of kick back and just see the fruit of labor. Like if I were to actually keep you with me as I'm trying to find this iOS version that I needed, you'd be like, man, Cisco's a painful career to get in. All right, so anyhow, I now have it. So let me get logged back into all of these routers. As a matter of fact, I'm just going to stick back on router 1 for now. So just for the record, in case you're curious, I'm now running the 12.4 release 15T. T is the key to EIGRP for IPv6. A lot of rhymes in there that weren't intended. So I'll do a show IPv6 interface brief just to get that plastered up on the screen so I can see it. Okay, so to make EIGRP run, like I said, it's a really easy config. Finding the iOS is probably the toughest part. So I'm going to do IPv6 router. Now we've got it, EIGRP, and then what autonomous system we want. Let's just throw out 100. So underneath here, you can see if I hit the question mark, we've got filtering commands and all that. But you notice there is no network command. The closest thing I've got is neighbor, but no network command like there was in IPv4. The biggest thing I need to do under this is a no shutdown. I know, it's kind of weird, huh? It's like we're unshutting or powering on a feature. Now I just go under each individual interface I want to enable for IPv6. I'll do interface S0/0 IPv6 EIGRP for autonomous system 100. Done. Seriously, that's it. Fast unit 0. IPv6 EIGRP, done. That's it. Show IPv6 protocols. We've got EIGRP running. It's actually already calculated those interfaces. See how much easier they made it? No wildcard masks, no nothing. You just say, that interface is doing it. That interface is doing it. That interface is doing it. So you go through and set up all your interfaces that are connected, and then you form neighbor relationships. So let's hop over here, show IPv6 interface brief. By the way, this iOS version, my computer is on fire. I did not want to take the time to calculate the idle PC value for GNS3. So how do you take an 8-core, is that what you call it? 8-core? No, 2-core. There's a lot of processors in this computer, and they're all blazing right now because of GNS3. So config T, router EIGRP 100, scratch that, IPv6 router, EIGRP 100, no shutdown, exit, interface, fast Ethernet 0/0, let's get some neighbors going, IPv6 router EIGRP 100, not 1000, I gotta back that out, no, there we go, and then we'll do, that's strange that it would just drop me back out to, I wonder if it thinks I'm trying to configure the, what am I doing? Where am I? Hang on, I'm totally on the wrong track. IPv6 EIGRP 100. Sorry, I was typing in IPv6 router, and it was taking me. Hey, that's okay. That's what I was wondering if I would see that neighbor form. So it was actually just taking me back into the router config mode. So forgive me. IPv6 EIGRP, not router EIGRP. Okay, back out of that. Okay, and then interface serial 0/0, right? Because we've got one of those. IPv6 EIGRP 100, and can't leave router 3 out in the cold. Where are you, router 3? There you are. Nugget love. Nintendo show IP v6 interface brief. There we go. You can see I added an extra little bonus network here on fast Ethernet. I just wanted a bigger routing table. So I'll do router EIGRP IPv6 router router. It's going to take me a long time. Maybe there will be like a slow migration and I'll get there, but I'm just not used to typing those IPv6 commands. No shut, interface fast Ethernet 00, IPv6 EIGRP 100, and 0/0, and there we go. Good. Neighbor relationship is up. So same show commands as EIGRP, show IPv6 EIGRP neighbors. Instead of show IP EIGRP neighbors, just show IPv6. You can see they're forming neighbor relationships using that link local address between each other. So they're communicating. So let's do it. We're on router 3. Might as well see the whole landscape. Show IPv6 route. And there we go. Notice we've got EIGRP routes coming in. So router 3 is seeing now via EIGRP, that's our code, 2001:11, which is our connection here to the ISP, 2001:12, which is our connection between router 1 and router 2. These, by the way, these networks, if you didn't figure it out, are just the router 1, router 2, anyway. So yeah, let's hop over to router 1. It's almost like I need like theme music, like that happened so fast and it was so easy. I need to be like, da-da! A couple fire like. What am I doing? Show IPv6 route. So we've got EIGRP. It's learning about that. Come on, we got to do a ping, right? Ping 2001 : by the way, ping IPv6 is optional, but you can put it in there if you want. I'll do 33::3 is router 3's address, and we are getting there. Let's do a trace route, 2001:33:3. Can you feel it right now? Like, I'm feeling it. I'm going to be typing someday next to some young whippersnapper, and I'm going to be like, oh, man, I remember the day when I would type in ping 192.168, and he's going to be like, you're so old, dude. Like IPv6 will be everywhere. Nobody's. We've all got chips in our left arm because we're chipped with an IPv6. Anyway, the matrix continues. So that is EIGRP. EIGRP for IPv6. Okay, let's take a look at OSPF. OSPF for IPv6 is now called OSPF v3. Probably guessed it. OSPF v2 was the one for IPv4. I'm sure the thought just entered your mind just like it did mine. So what was OSPF v1 for? I don't know. So I paused and I go to Google. What is OSPF v1? It's like, it is so old that nobody remembers it. And it's not supported by anyone if it ever was. But then he's like, please note, without being offended, if you're an end user, it is recommendable that you have a network design and implementation to a reputable consultant or certified Cisco partner. So I haven't even read the thing up there, but it's like, the fact that you're even asking this question tells me you shouldn't be configuring a Cisco router. So let's not ask. So network design in OSPF v3 is the same. So we've got the same areas, area borders, border routers, autonomous system boundary routers, all of those concepts that we've come to know and love through ICND 1 and ICND 2 is the same. Now, what's different is instead of having the multicast address of yesteryear, the OSPF v2 of 224.0.0.5 and .6, we've now converted that to an IPv6 multicast, FFO2::5. This is going to be for all OSPF routers. And then .6, which is going to be for the DR and BDR. Remember the kind of the king and queen of the broadcast-based network, so you don't have to have full neighbor relationships with everybody. So concept is the same, just new IPv6 compatible multicast addresses. Now here's an interesting one. They decided to keep the router ID still in an IPv4 format. Now, you might remember the router ID in OSPF is the name of the router. Essentially, all routers in the OSPF network will have one name. So router 1 might have a router ID of 1.1.1.1. That's the kind of thing I usually do when I'm in a lab environment. It's just assign. It's not a real IP address. It just looks like one, and that's how all of the other OSPF routers know it. Now the reason this is worth bringing up is because when you start the OSPF process, it's going to follow the same method that it did in the IPv4 day, which is going to look for the highest IPv4 interface and use that IP address as its router ID, whichever one has the highest IP address. Or, remember, loopback addresses always win, so the highest loopback interface would be chosen. But the reason I'm even bringing this up, because, frankly, most of the time we don't really care what the router ID is. It's just kind of one of those things that happens. The reason I bring it up is as we are now moving to IPv6, you may soon encounter, well, I won't say soon, but someday, you may encounter OSPF routers that don't have IPv4 anymore. Like we've completely converted them to IPv6. So when we start the OSPF process and try to form neighbors, it will actually fail because it will say, I'm sorry, I don't have a router ID. It doesn't have any IP addresses on any interface that is an IPv4 format that I can choose. In that case, and actually I would say just as a general best practice, you need to go under the IPOSPF process and use the, I don't know why I'm writing IP, it's the router-ID command. Remember that one? You go under router OSPF, type in router ID, and then whatever you want the router ID to be, 1.1.1.1.1. And that hard codes it, and now it has a router ID to start up. So same thing as EIGRP, enabled per interface instead of using the network command. Let's take a look. Well, I've gone back and reverted the topology to the previous flavor. So no EIGRP. Actually even went back to my older iOS because that idle PC was destroying everything. So let's go through and look at the OSPF configuration. So I've got router 1 right here. Show IPv6 interface brief. Same IP addresses. Yes, I just want to make sure we save the configuration. But when I do a show IPv6 protocols, we've got none. There's no routing protocol. So again, just like EIGRP, I'm going to go in and do an IPv6 OSPF, or actually router OSPF. And this time we type in the process ID, which can be anything. It's not the same as the autonomous system like it was with EIGRP. You notice once again that we have no network command underneath here. Also notice that OSPF doesn't have the no shutdown command. It just runs by going in here. Now, one of the things I would like to do, just to get in the habit of it, is before I go any further, set the router ID. Now I'm on router 1, so let's make it 1.1.1.1.1. And I'm going to exit out here. And then go underneath the interfaces. So let's go under let's go serial 0/0. Similar to EIGRP, IPv6 OSPF, but then we just type in what process ID I want to assign it to. So I'll say process ID 1. Now question mark area. So it says, okay, what is your area? Remember, with OSPF, we always have to have areas. So I'll say area 0. This is going to be the backbone. So looking back at the diagram over here, what I'm doing is I'm saying, okay, well, this is now area 0 for OSPF. Matter of fact, we're going to have this entire thing be area 0 by time it's said and done. But now all we have to do is start adding in all of the interfaces to OSPF. That's seriously, this is it. So interface fast Ethernet 0/0, up arrow, IPv6 OSPF 1 area 0. Okay, so let me jump over to the other routers. Router 2, I'm going into global config mode, interface fast Ethernet 0/0. Oh, actually, IPv6 router OSPF 1. Let's set the router ID 2222. Exit back out. Interface fast Ethernet 00, and we'll do the. Actually, I think it's still on my. Nope, it's not. IPv6 OSPF. Process ID 1, area 0. So that should form a neighbor, is my guess. There we go, by the time it's done. So we've got the neighbor gone to full. Then we can go under interface 00/0 and do this. Isn't it, I mean, just think about it. It's so much easier without that network command. So yes, it's changed from what we're used to, but it's just a couple commands to enable these routing protocols now. Really just a piece of cake. So let's bring router 3 into the mix. Config T. IPv6 router OSPF1 router ID 3s 00 IPv6 OSPF 1 area 0, right? Did I type that on the other one? Area 0. Okay, good. Just want to make sure. And then let's go into fast Ethernet 00, and we'll do IPv6 OSPF1 area 0. So it's all in one big area. Now, honestly, let's talk CCNA exam for just a second. That's all Cisco cares about. It's just like IPv6 is still so fringe for most organizations that they just want to know that you know about it and that you have enough knowledge to be dangerous, if you will, with IPv6 to where for OSPF you can turn it on. And then because what Cisco's thinking by doing it this way is they're like, hey, you know the concepts from IPv4. You know about areas. You know about summarization. You know about router IDs and DRs and media. They're kind of like, once you've got the base down and you kind of know, okay, well, this is how we do it. Show IPv6 OSPF neighbors. See my neighbor relationships that I form. I mean, it's kind of like, why do we need to explain everything all over? Because now that you know the basics of the IPv6, you're going to be able to figure all of it out. So let me just do a quick show IPv6 route. And now we can see OSPF routes coming in. Router 3 now knows about the network. So same thing as EIGRP. We now have the full routing table thanks to IPv6. Let's just finally do a show IPv6 protocols. Verify OSPF. It's like, there's a lot of info there. OSPF 1, there's our two interfaces. I'm guessing that the iOS that I'm using, Cisco's like, okay, let's introduce IPv6 in this one because I'm definitely feeling a lot of shortened love on these show commands to where I don't see hardly anything. Oh, last thing. I want to do a show IPv6 OSPF interface. Big one, because that one allows you to see hello timer. Again, same thing as the IPv4 days, but hello timers, dead timers, all those have to match in order for those neighbor relationships to form. So there it is, the routing protocols for IPv6. Now, as I was sitting here thinking, I was like, how do I summarize this? Because it was so fast. And then I thought, well, you know what? There's hardly anything new. It's all the same concepts that we've talked about in the IPv4 world. It's just now we've got these big ol' addresses that we are just getting used to, and then just some slightly different ways of enabling the same features. So it's more of like, hey, remember we used to do it this way, now we do it this way. So I hope going through this, you guys are like, okay. So I really am just learning some new commands to enable all the same things that I learned back in the IPv4 world. All right. Well, I hope this has been informative for you, and I'd like to thank you for viewing.